When we're talking about buoyancy, we're generally trying to answer the question of, will it float? Whether an object floats depends on the density of the object and the density of the fluid it's being placed into. If the density of the object is less than the density of the fluid, then it will float. If the density of the object is more than the density of the fluid, it will sink. Now, when we talk about density, we're talking about the amount of mass per unit of volume. Or if we look at it in an equation, we're looking at density being equal to the mass divided by the volume of the object. The standard units that we use for density are grams per cubic centimeter. All objects, whether they sink or float, when placed in a fluid such as water, will displace that fluid. How much fluid is displaced is dependent upon the mass of the object. Specifically, any object placed in water will displace a volume of water equal to the object's mass. If we look at this more specifically, a 1 gram object will displace 1 gram of H2O, or water. Now, since the density of water is 1 gram per cubic centimeter, this also means that that same 1 gram object will displace 1 cubic centimeter of water. And a 25 gram object will displace 25 cubic centimeters of water. If that 25 gram object has a volume greater than 25 cubic centimeters, it will float. So in order for an object to float, it has to have a volume greater than the volume of water its mass will displace. Another way we can look at this is forces. Now let's say we have an object that's 25 grams and it has a volume of 50 centimeters cubed. Now there's going to be two forces acting on this object. One, the force of gravity, and the second is the buoyancy force. Now the force of gravity acts downwards towards the center of the earth, and its magnitude is equal to the mass of the object times the acceleration due to gravity. We can determine the force of gravity acting on this object by multiplying the mass of the object times the acceleration due to gravity. In this case, that works out to about 0.25 newtons. When we're looking at the buoyancy force, we can use this same equation of the force being equal to the mass times the acceleration. The mass in this equation is different because it's the mass of the volume of water that the object displaces. In this case, when we calculate it, we determine that the force of buoyancy is equal to approximately 0.49 newtons. Now in this situation, since the buoyancy force exceeds the force of gravity, the object floats. Now, in order to determine if an object will float, we have to look at the volume of water that the object will displace and use that to determine the force of gravity acting on that object and the buoyancy force acting on that object. As long as the force due to buoyancy is greater than the force due to gravity acting on that object, then the object will float. Now, if we're looking at a situation like whether or not a boat will float, we need to be able to determine the volume of that object so we can determine how much water it will displace and how much mass that displaced water will have. This will allow us to do those calculations to determine both the buoyancy force and the force of gravity acting on that object.